Hi, and welcome back to Algebra 1. Our goal for today is to continue working with linear equations and finding solutions of that linear equation and taking those solutions and recording them in a table of values. Our ultimate goal here will be to use those solutions to help us make our graph, which is our picture version of our solutions. Please remember with linear equations, there are infinite solutions, right? It's a line, it goes on forever. So we're just finding 4 locations on that line so that ultimately we could take those 4 points, plot them in a coordinate plane, and connect to show all of the solutions because there's an infinite ongoing amount. We have different ways we can show that we have a linear relationship. Option 1, and for all of these, we'll have a degree of 1 on our x term. That tells us it would form a line in picture format. So we have y equals kx. And if this had numbers in it, it would look something like this. y equals 5x. Right? That would be our what's called proportional relationship form of a line, where this 5 right here is the slope of our line, and it has a special name when it's in this y equals kx format called the constant of proportionality. Type number 2 that we might see that represents a linear relationship. Again, we know because this x has an x to the first power, right? The highest degree on x is a 1. That's going to form a line when we go to graph it. And if this had numbers in it, it would look something like this. Y equals 5x plus 2. Where this 5 is still the slope of our line, and this 2 is actually what's called the y-intercept, or the place where our line crosses that y-axis. All right, type number 3 that we could see that we, in our head, should go, wait, that would be a graph that forms a line, is in the format of what's called point-slope format. And if there were numbers in here, it would look something like this. Y minus 2 equals 5 times x minus 1. Where this 5, again, is our slope of our line. And then this 2 and this 1 that are here is one of our solutions on our line. It's a point we know. So 1, 2. Now be careful. Remember, this has to be x, y. All right, so this is the x back here. Even though it's in the back, it goes first in the order pair. All right, that's a point we would know on our line. And then we'd also know that that line has a slope of positive 5. All right, type number 3, what's called standard form of our linear equation, where we have an x term, a y term equaling a constant term. So something like this, 2x plus 3y equals 9. Right, that would be a linear relationship given in standard form. And now we finally have this what's called function notation form. This side over here that gets read, f of x, right? What's the function when x is something? It's the same as putting y, right? This f of x is still our y variable. And then over here, it looks like slope-intercept form. So with numbers in it, it would look like this. F of x equals, again, we could have like a 5x plus 2. This is still our slope of our line. This is still our y-intercept of our line. And we can think of this f of x portion of our equation as our variable y. And we have some special cases that just have x or just have y. So something like this. X equals 3, y equals 5. Right? We could have those special cases. They would still form lines. The thing that makes them special is they would be perfectly straight up and down or perfectly sideways, right? No diagonal, no slant to them. Or the vertical lines, right, that would look something like this, and they would have slopes that are undefined. And our horizontal lines would look something like this with 0 slope. So really, these special cases are just when our slopes are undefined and 0. We'll get to those later on. So our goal for today is to continue working with these top ways we can be presented with linear equations and creating a table that has 4 solutions or 4 places that would be on that particular line. Remember, there's an infinite amount. We can pick whatever x values we want and solve for the y for that particular equation. However, in our previous lesson, we talked about picking out x values that would be easiest to use, smallest to use, and give us perfect y locations. So for today, I'm not going to give you x values. We're going to pick out the 4 smallest, easiest to use x values so that we don't get decimals or fractions for our y's. So remember, my suggestion to you is I want one of these x values you're picking for your table here to be a negative. So -1, 0, 1, and 2 would be probably the 4 smallest, easiest x values to use. So if it doesn't matter what our x values are, my suggestion would be to pick those. Remember, we can pick whatever we want here, but those are going to be the smallest, easiest numbers to work with when we substitute in, and they give us the best possible chance that they would fit in a 10 by -10 or 10 to -10 coordinate plane without having to change anything on any of our axes. Now, remember, when our coefficient in front of x, coefficient is just a fancy word for what number is in front of x. When that number is a fraction amount, then using -1, 0, 1, and 2 here would work, right? It would give us locations on our line, but they wouldn't be easy to graph because remember that our ultimate goal is to take these points we solve for and put them in their picture format, right? So they would give us fraction or decimal y values, which would be really tricky to put into our coordinate plane. So the trick here is you look at your denominator of the fraction and you take that number and you multiply these by that number. That's going to give you the 4 smallest, easiest x values to use that will end up giving you perfect y's that aren't decimals or fractions. So instead of -1, -1 times 9, we would use a -9. This 0 times 9 is still 0. 1 times 9 would now be a 9. And this 2 times 9 would give us an 18. And those would be our 4 smallest, easiest x values to use that would give us perfect y's that aren't decimals or fractions. So what we're going to do today is when we get to our function form or our y equals form, we're going to look at that coefficient in front of x and say, can we just use -1, 0, 1, and 2? Or should we be smarter about picking out our x's so that we get perfect y's? So let's look at one more like that. All right, that top one, it's in slope-intercept format of y equals mx plus b, of y equals 4x plus 2. Our coefficient number here in front of x is not a fraction. So -1, 0, 1, 2 would be our smallest, easiest x values to use that would give us perfect y's, right? We could put anything in there for x and we won't get fractions or decimals. So all solutions here that we pick out for x and solve for y will end up with giving us fairly simple, easy things to graph. Now, this bottom one, which looks a little bit different, it's also in slope-intercept form of y equals mx plus b, but our coefficient here in front of x is a fraction. So we want to look at this bottom number. It's going to help us pick out x's that are a little bit easier to work with and will give us perfect y's. So instead of this -1, 0, 1, and 2 here, we're going to take those and we're going to multiply them by 4, right? We're using this denominator and multiplying by that number. If we use that denominator, then when we go to multiply, right, our 3/4 times whatever we substitute in for x, we'll get perfect numbers that aren't decimals or fractions. So instead of -1, we're going to take that -1 and multiply it by this 4, and we'll get -4. All right, so instead of this -1, we're going to use a -4. 0 times this 4 is still 0. 1 times this 4 would give us a 4, and this 2 times 4 would give us an 8. So our 4 smallest, easiest, simplest x values to use here, instead of -1, 0, 1, and 2, would be -4, 0, 4, and 8. So let's go. Our goal for today is if I give you a linear equation, no matter what format, can we pick out x's that are our smallest, easiest ones to use that will give us the first 4 smallest, easiest, perfect y locations on our line? So picking up where we left off in our note packet from our previous lesson. And we're going to look at one that's starting in point-slope format. Now, when we're given point-slope format, which in this case we're given y plus 6 equals 3 times x minus 4. We're definitely not in function form. So we want to start there first. We definitely have work to do in this first block. So we have y plus 6 equals our 3 times x minus 4. All right, to get this in function form, we want to start with a distribute. Now, there's nothing technically out here. So remember, that's a positive 1 that's going to get shared to y plus 6. So 1 times y and 1 times 6 would just give us y plus 6 still. Over here, this 3 has to get distributed to x in negative 4. Be careful there. So 3 times x would give us 3x, and 3 times negative 4 would give us a minus 12. Be careful there with your sum. All right, we want to get this y by itself. So here's our side we're looking at. We need to get rid of an add 6. So we need to subtract, and the amount would be a 6 from both sides. Now be careful, this is a negative 12 minus 6 that are like terms that can go together. Over here, these will cancel. We'll have y equals, which is what we wanted, 3x, and then negative 12 minus 6 would just give us a negative 18. All right, now once we're here, we can go over here and think about, should we use negative 1, 0, 1, 2, or should we take those and multiply it by something, right? So we look at our coefficient here in front of x. If it's a fraction, we want to do our work down here, multiplying by the denominator. If it's a whole number like it is here, then negative 1, 0, 1, and 2 will give us perfect y's, and they're the 4 like smallest, easiest ones to work with. All right, so let's go ahead. Let's do our work here for that. So we're going to use y equals 3x minus 18, and we're going to substitute in x equals negative 1. All right, let's start there. So y equals 3 times negative 1 minus 18. PEMDAS from there, multiply before we subtract, and we'll end up here with negative 3 minus 18, which would give us a negative 21. So one of the locations on our line that could be described as y plus 6 equals 3 times x minus 4 would be at the location of negative 1, comma, negative 21. Or this ordered pair, negative 1, comma, negative 21 is the solution of that particular line. All right, let's find another. How about when our x value is 0? All right, we're going to put in a 0 here. All right, so y equals 3 times 0 minus 18. PEMDAS from there, multiply first. So 3 times 0 will give us 0 minus 18. So 0 minus 18 will give us a negative 18, which means 0, comma, negative 18 is another solution on our line. All right, 2 more. Let's go when y equals a 1 this time. Or excuse me, x equals a 1. What would be our y? So y equals 3 times 1 minus 18. PEMDAS from there, 3 times 1 is 3 minus 18 would give us a y value of negative 15, which means 1 comma negative 15 is a location on this line. All right, y equals 3x minus 18, and now we're going to say what would our y be if our x now is a 2? So y equals 3 times 2 minus 18. PEMDAS from there. Multiply first, then our subtract. 6 minus 18 would just give us a negative 12, which means the point 2 comma negative 12 is a place on our line. So in our next lessons, we're going to look at, once we know these solutions, can we graph those and then connect them to form our line that would represent all of the solutions on that line, y plus 6 equals 3 times x minus 4. All right, let's look at another one. All right, we're going to look at function notation. This one's a little bit goofy. This front side, f of x, is how you would read it. It doesn't have to be a letter f. It could be g of x or h of x or p of x, right? But usually, since it's describing a function, we use this letter f, but it just doesn't have to be. This side where it's f of x is the same as just putting a y there, right? Those are sort of the same thing. That's your output, right? We're still picking x's that go here in our equation to solve for what this f of x or y side would be. So it's going to look something like this. F of x equals like 2x minus 1, right? We're putting in x's here to solve for what we would get over here, just like we were before. All right, now, the nice thing about function notation is it's in function form, right? F of x equals 1/2 x minus 7. We don't have any rearranging. That's the same as saying y equals 1/2 x minus 7. Right, those are the same. It's just a slightly different notation, which means our work over here when we're doing our steps to figure out our solutions is a little bit different. So I'm going to show you what that looks like. Now, we want to think over here if we can use -1, 0, 1, and 2, or if we should take these and multiply it by something. So look at this coefficient in front of x. And since it's a fraction, we want to pick better things. If we use -1, 0, 1, and 2, we're going to get y's that are on our line. Right? They're going to be locations on our line. They are solutions. They're just really tricky ones when we go to the graphing portion. So we're going to take it and multiply here by 2, which is our denominator. So -1 times 2, we'd use -2 here instead of this -1. 0 times 2, we'd still use a 0. 1 times 2, we'd use a 2. And this 2 times 2, we'd use a 4. All right, so really any multiple of 2, 4, 6, 8, 10, 12, 14, or -2, -4, -6, -8, all those would give us y's that are perfect locations that would be easy to graph. All right, so now here's where things get a little bit different. This is our x, and this y is really our f of x, or this is our input, this side's our output. So f of x, we want to know what would be the value of this function when x is -2. And the way to show that is f of -2. Right? That's the same as when I was putting over here like x equals -2. Right? That sort of replaces that. All right. So we no longer need that, right? Because we're just going to say, here's what I'm inputting. This is what I'm inputting. I'm putting in a -2 into the function. So 1/2 x minus 7. So what's f of -2 is the question here. All right. So f of -2 equals 1/2 times -2 minus 7. And now we're right back to the same thing. Remember, this f of -2 side is really like our y. Right? We're not doing, there's no math to do over there. That is not a multiplication problem. We're saying, what's the value of this function when x is -2? There's no math to do over there. So just be careful. All the math's over here on this side. So 1/2 times -2 would just give us a -1 minus 7. So the value of our function when x is -2 would be a -8. All right, so one location on this line is at -2, -8. All right, let's do the same thing for f of 0. What's the value of the function when x is 0? All right, we're taking this 0, right? It gets substituted in. So f of 0 equals 1/2 times 0 minus 7. All right, 1/2 times 0 is just 0. So 0 minus 7 would give us a -7. So when our x value is 0, the f of x value or the y value or the output value is a -7. All right, let's do our f of 2. What's the value of this function when x is 2 is our question there. All right, so this 2 is going in for x is what that means. So f of 2 equals 1/2 times 2 minus 7. Now remember, this side over here, there's no math to do. That's not a multiply. It's just saying, what's the value of this function when x has a value of 2? That's it. All the math is over here on the right. So 1/2 times 2 gives us a 1 minus 7. And then we subtract here. We'll figure out that our value of our function when x is 2 is a -6. So another place on our line is at 2, -6. All right, last one that we're going to solve for here. What's the value of our function when x is a 4? Really just means take this x value and stick it in and do our math. Again, over here, f of 4, there's no math to do over there. That is not a multiply, so be careful. All right, all the math's over here on the right. So what's the value of our function when x is 4? 1/2 times 4 gives us a 2 minus 7. So our function when x is 4 equals a -5. Or the location 4, -5 is another perfect spot on our graph. And then we can use these 4 locations to plot and connect to draw on our entire line. All right, so let's look at one more in function notation because these are a little bit good. Now this one's written as h of x. H of x equals -4/3 x plus 2. Again, that's the same as saying y equals -4/3 x plus 2. So don't be confused by that. H of x is just saying we have a function named h, and we're going to evaluate things for the value of x. All All right, let's think. We want to pick out the 4 easiest, smallest things here. We really would like to use -1, 0, 1, and 2 if possible, but we might have to take that and multiply it by something. So we want to look, because we want y values that are perfect, easy locations to ultimately graph. So we look at our coefficient here in front of x. It is a fraction. So if I use -1, 0, 1, and 2, I'm going to end up with y's that are places on our line, right? They're solutions. They're just going to be really tricky to guesstimate their location, right? If I get like 2 2/3, right? That's kind of hard to put in a coordinate plane. So we want to take our bottom number, our denominator number here, and multiply these by that number, or any multiple of 3 would work for our picking out x's to solve for perfect y's. So -1 times this 3, we'll use -3 here instead of -1. This 0 times 3 just gives us a 0 still. 1 times 3 gives us a 3. 2 times 3 gives us a 6. So 3, 6, 9, 12, 15, -3, -6, -9, right? Those would all give us y's that would be perfect, easy to graph locations on our line. All right, let's evaluate h of -3 when we have the function -4/3 x plus 2. All right, we're taking this -3 and we're substituting it in. Remember, on this side, h of -3, that's just like saying y equals. There's no math to do over there. That's not a multiply. All the math is over here on the other side. There's a multiply and an add. So multiply first. H of -3 equals -4/3 times -3. A negative times a negative is a positive. In this case, a +4. If you can't do that in your head, that's fine. Use your calculator, use your fraction button to help you get that number. All right, 4 plus 2 then would give us a value of 6. All right, so one location on this line would be at -3, 6, or go to the left 3, up 6. We can put a point there. It's a place on this line. All right, what's the value of our function for h of 0? When our line can be described as -4/3 x plus 2. All right, we're taking this 0, substitute it in. H of 0 equals -4/3 times 0 plus 2. No math to do over here. It's just what's our function when x is 0. Over here, multiply first. We'll get a 0 plus 2. So h of 0, or our function for the value of x, would have an output or y value of 2. Remember, this is input. This is output. We usually use those words with function notation, but it's still our x's and y's. So 0, 2 is the location on our line. Or in this case, our y-intercept, right, of our line would be up 2. All right, what's our function of h of 3 when our linear relationship can be described as -4/3 x plus 2? All right, we're taking this 3 and substituting it in. H of 3 equals -4/3 times 3 plus 2. Remember, this side, h of 3, there's no math to do there. That's not multiply. Everything's happening over here. So -4/3 times 3. Again, if you can't do that math in your head, use your fraction button on your calculator. -4 ABC 3 times 3 would just give you a -4 plus 2. All right, we got to finish with our add. So h of 3 would equal a -2. So another location on this line would be at 3, -2. All right, last one, we want to know what's h of 6, or what would be the output if our input value for x is 6. All right, so that 6 value goes in for x, and we evaluate from there. So h of 6 equals -4/3 times 6 plus 2. Over here, h of 6, there's no math to do. Please don't multiply those. Everything's happening over here. All right, -4/3 times 6. Again, if I can't do that math in my head to get -8 here, use your calculator, which is perfectly fine. So h of 6 equals a -6, which means 6, -6 is a location on this line. All right, I hope that helps you attack your work for today. See you guys later.